So hello friends, once again to DD tutorials. We dream, we design and we deliver. Myself your DD sir, and today we are going to start with our new topic. The name of topic is electrode potential. First of all, we need to read what is electrode. As we know, the rod of the metal which are been dipped in the electrolyte solution are known as electrolyte. Let's go with the definition. The tendency of a metal to get oxidized or reduced when it is placed in a solution of its own salt is called electrode potential. For an example, let us take a zinc rod deep in a zinc sulfate solution. When a metal M is placed in a solution containing its own ion M+, then the metal may undergo either oxidation or reduction. If it goes oxidation, then there will be a loss of electron, and if it goes reduction, then there will be gain of electron. Now let us go for the concept of electromotive force of a cell. Electron flows from anode to cathode in external circuit due to a push effect called electromotive force. It is also known as cell potential or electrode potential. Its unit is same volt. Its formula is E cell is equal to reduction potential at cathode minus reduction potential at anode. If you can remember this both formula, it is valid, but just remember first one because it will be mostly used. Reduction potential at cathode minus reduction potential at anode. Which electrode of galvanic cell consider the higher potential? Let us discuss it afterward. Is a question for you all. Now we will go for sign convection of an EMF. If this, let us consider this cell Zn plus Zn4 copper sulfate plus copper sulfate. Its E naught is 1.1 volt, and here for this cell it is minus 1.1 volt. Here you can see that the reaction is feasible and their reaction is not feasible. We will be discussing it after we will be understanding the concept of Gibbs free energy. Now let us take an example over here. Is for this cell reaction given over here, E naught is, we are given the E naught of the cell 1.8, and we are given E naught for cobalt plus to cobalt, and we need to find E naught for cesium. You can see over here that E naught is equal to reduction potential at cathode. Here cathode will be cesium and anode will be cobalt. Okay, so you can see over direct basing the formula, you get the answer. Now we need to find relation between delta G and electrode potential. Let n Faraday charge is taken from a cell of EMF E, then the electric work done will be equal to charge into potential. So total charge is NF and potential is E, so work done will be equal to NFE. But from thermodynamics we know decrease in Gibbs free energy of is measurable as reversible or maximum work done. Hence change in Gibbs free energy will be equal to the negative of work done, which will be delta G will be equal to minus NF E naught of cell. From thermodynamic law, delta G is negative for spontaneous process. Now let us go back. We know that formula over here is this. Now let us go back to the topic here. If delta G will be negative, then only the reaction will be possible. If E naught is positive, then only delta G is negative. Hence this reaction is feasible and spontaneous. This reaction is spontaneous and this is not spontaneous. Okay. Now you can see over here when delta G is positive, E is negative, and cell process will be non-spontaneous. Okay. Now we will be discussing the most important topic. For the standard condition under the temperature 298 Kelvin and pressure 1 atm and the concentration of the electrolyte will be 1 molar, we use this formula. E naught is equal to E cell minus E naught reduction minus E naught of oxidation. But what if when the conditions are non-standard, means temperature is not equal to 298, pressure is not 1 atm, or the pressure or the molar concentration is not 1 molar, then we will be using Nernst equation, and which we will be discussing in our next lecture. Friends, the most of the Nernst equation is the most important topic of this chapter, because in the previous year of JEE and boards, one question is confirmed from the Nernst equation, and for JEE